Okay, so welcome back, and now here is the list, or a list. There's a couple of them I couldn't get on here, so I'm going to write those down in a minute. But here are what we call the limit laws. Now I've combined the first two, the sum and the difference laws. Okay, I didn't write down the names, but I'll give you the names as I go through these. So Theorem 2 says, let f of x and g of x be defined for all x not equal to a over some open interval containing a. Assume L and M are real numbers such that the limit of f of x is equal to L. So the limit of f of x as x approaches a is equal to L. And the limit as x approaches a of g of x is equal to M. Also, let C be a constant. Then each of the following statements holds. Now I combined the sum law and the difference law for limits. Okay, so I just put a plus minus in here because it works for sums and differences. So what this is saying is the limit of a sum or difference of functions is equal to the the limit of the sum, right? So the limit of the sum or difference of two functions is equal to the sum or difference of the limits. So, which means you can basically distribute the limit across addition and subtraction, okay? And then you could handle these individually, so then you end up with L, the sum of the two constants, the two limits, or the difference of the two limits. The next one is called the power law, or excuse me, the constant multiplied by a constant, okay, or the constant multiple law. So here we have C as a constant, and we're multiplying by the function in limit. So the limit of this is equal to the constant times the limit of the function. So what this means is you can always take this constant out, okay, and then you get C times L. So you can then handle this separately, and you get C times L. Okay, and then the product law is dealing with multiplication of functions. So the limit of a product is equal to the product of the limits, which means again you can kind of split this up into two separate products. So the limit can be distributed in a sense to the function. So again, the limit of the products is equal to the product of the limits. And then you can handle the limits separately and you get L times M. Okay? And then you also have a quotient law, which does pretty much the same thing that we saw with multiplication. So the limit of the quotient is equal to the quotient of the limits. So you can distribute the limit to the numerator and the denominator and handle these separately, and then you get L divided at M, provided that the denominator limit is not 0. Okay? Can't have 0 in the denominator. Okay? Now, the next two deal with powers and roots. So let me write that down. So number 5 that I have is the power law, and it's the limit as x approaches a of f of x raised to the power of n. Okay? And so what this means is you can pull the limit into, you can put the limit into the power. So the limit of the power would be the same as the power of the limit. So we can write this as the limit as x approaches a of f of x, all raised to the power of n. And then of course we could do this limit inside, which again is L. And so we get L to the nth power. Now similarly, the last one is the root law. So we apply this to roots. So we can take the limit as x approaches a of the nth root of f of x. And again, we can pull the limit inside the radical, and we can write this as the nth root of the limit as x approaches a of f of x, which then equals the nth root of f. And that is the root law. And those are the laws. Oh, by the way, again, because of the radical, we have to have L has to be greater than or equal to 0, right? You can't have negative numbers under the radical sign. If n is even, right? Oh, and if f is positive, okay? So if n is even, right? If n is odd, it doesn't matter. Remember the properties of radicals, of roots. So if n is even, right? This applies if n is even and f of x is positive. Okay, so greater than 0. Okay, those are the limit laws. So now we're going to do some examples and start applying these. Take care.